Hello, it is me again. I am going to show you how to do a few more conversions here, and these are all going to involve um, the liter. So one of the things that we haven't talked about, we've talked about moles, molecules, and grams, but we have not talked about how to do a conversion to liters with those. And so this one has one conversion factor that we're going to use. And the rule for it is that a mole, and this should be of a gas, okay, a mole of a gas at standard temperature and pressure is 22.4 liters, okay? And so that's the conversion factor we're going to be using, okay? And so it's a pretty easy, if you, with everything else that we've done, you'll find this to be fairly easy. So again, we have, I'm just going to come over here, 5.00 liters of neon. And I know that 1 mole of neon will have a capacity, a volume of 24 liters. Okay. And again, it would be of neon. And so you'll see that these will cancel and it just becomes a division problem. Okay, so we'll have 5.00 divided by 22.4, and then the answers will be moles of neon. And again, you can just run that in your calculator. So it is just a one-step problem that you're going to be doing here if we're just doing this conversion. So it would be, let's see, we have 3 digits, so 0.223 moles of neon would be my final answer. Okay. So let me give you, I'm going to skip a little bit here because this is what we've been doing molecules to. So again, that's accounting. We're going from molecules to moles. Molecules again is a count. So this one we'll use Avogadro's number. So you do need to get used to being able to see these all mixed up. So here again is a liter. I have 1.5 liters of xenon, and I want to know how many grams it is. Now this one might require a little bit of extra work because again, I have liters here, I need liters here. So I'm going to my conversion, which is 22.4 liters for 1 mole. Okay. Those are going to cancel. Now, here's where we're going to add in what we've been doing because it's not asking for moles, it's asking for grams. And so here's my mole to gram conversion that we've been doing. So 1 mole of xenon is how many grams? And so again, that's going to my periodic table and finding xenon. And this is where we're starting to use our noble gases. Okay, 131.30. Okay. Almost didn't leave space there. So your moles are going to cancel, and there is going to be my final answer. So I'm going to multiply again, guys, and we've done this multiple times. When you see this, I'm going to multiply across the numerator. Okay. If again you need this over 1 to help you see, then do that. And then again, we're going to multiply across the denominator. So there is my multiplications. So I need 1.5 times 130, 131.3. So this is 196.95. I multiply across, I get 22.4. Again, when I look at all my labels, everything's canceled except now I have grams of xenon. Okay. And then we're just going to divide that on out. And I have 3 digits. Oops, I dropped that off. 3 digits here, so I'm going to have 3 digits in my answer. So my final answer would be 8 point, in my book, I have 79 grams. Okay, so this one actually required 3 steps to it. Okay, 3 steps. Okay, this one is going moles to liters. So that's just going to be a 1 step because that's a mole to liter conversion. Okay. And so forth on there. So I would like for you to try a few of these on here. For sure, you need to do, which ones? And it may be that you need to use Avogadro's number. So like this one is in atoms. So we're going to need to go from atoms, okay, to moles. Again, that's Avogadro's number, okay? And then where are we going? From moles to, and then to grams, okay? So you got a 3-step problem here. So let's try that one. Try number 6, okay? And let's see if there's anything different here. And then 10, and then 12, 6, 10, and 12, okay? 6, 10, and 12. So try those and see how well you can do on those. Okay, I'm going to help you out just a little bit on 6, but hopefully you try to do it on your own. So again, we're starting off with atoms. I told you we were going to go to moles. To do that, we had to do Avogadro's number. So here it is, 6.02 times 10 to the 23 atoms to moles. And then we needed to go from moles to grams. And to do that, again, we got to use our periodic table and find our conversion factor. So again, when you go to do this problem, you need to multiply across the numerator and get that value, okay? And then you need to multiply across the denominator and then get that value and then divide them out, and you're going to have 3 significant digits when you're done. So go ahead and work those out and see what you get. Okay, help you out a little bit with number 10. So again, you're starting with grams. I've got to go to liters. And again, guys, if you look up above at your conversion factor, your conversion factor is moles to liters. So that means I've got to get it to moles. Okay? So we're going to take our grams and go to moles. And then we can go from moles to liters using our conversion factor up above. Okay? So even though I had grams, and again, this is from my periodic table. So number 86 is 222. Okay? And then again, you know, just to remind you, numerator, 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 all multiply together. Denominator, 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 all multiply together. Okay? And then try 12. Okay, and the final one on this page. So we started off with liters of krypton. We're going to grams. Again, I can't go to grams unless I have moles. So I do my mole to liter to mole conversion. Liters cancel, I've got with moles. Then I do my mole to gram conversion. Your moles cancel, and my final answer is grams. And that's all I have left. So then again, it is numerators multiplied together and denominators multiplied together. And then divide it out, get your sig digs. So that was a very quick examples of those, but just want to show you those before we go on.